In order to truly understand gas relationships, we must first understand what a gas is. A gas is a substance or matter which expands freely because it doesn't have a fixed shape or volume. Examples include air, helium, and oxygen. Gas relationships are defined by the gas laws. Gas laws were made in the 17th century in order to discover the relationship of pressure, temperature, and volume in the amount of gas. Real-life examples include hot air balloons representing temperature, syringes representing pressure, and regular balloons representing volume and the amount of gas inside of it. One of the gas relationships is Boyle's law, and the equation for Boyle's law is P1 times V1 equals P2 times V2. The example problem says a neon sign has a volume of 1.51 liters at a pressure of 635 torr. What is the volume of gas after it is pumped into the glass tubes of the sign, where the pressure is at 785 torr? So first, what you want to do is write down your units, so you can keep track and don't lose track of what you're doing. And second, you want to identify where they go. So we know torr is pressure, so we know that's going to be P1 because it's the first thing mentioned. So write that down. And then this is volume, so you write that down as well. Liters is volume. And then you see right here, here's the other pressure. This is P2, so you write that down right here. But don't forget to write the units too. So now we know we're looking for a V2. So we don't put a question mark right there. So basically we just plug it in now. Plug in our units, 635 times 1.551 equals 785. Pause it. Alright, so now we just do the math. 635 times 1.51. You get 958.85. That equals 785 V. Now we divide 785 by 958 to get V by itself. And then once we do that, your final answer is 1.22 liters. Don't forget that's what V2 equals. Alright, you can stop it. Alright, the next law is the charge law equation, which helps find for temperature and volume. So that's V1 over T1 equals V2 over T2 to get your answer. So the example reads, a bubble contains air at 28 degrees Celsius at a volume of 23 milliliters. As the bubble rises, the air around it is 18 degrees Celsius. What is the volume of the new bubble? So first you have to put your degrees Celsius in Kelvin. And the equation for that, you have to add the degrees by 273. So the first we're gonna add 28 because that's the first temperature. 273. When we do that, we get when we do that, we get 301 Kelvin. Make sure to plug that in over here to keep track. Next thing we do, we add the second temperature. We do 18 plus 273. We get 291. 291 Kelvin. Don't forget your units. So 294. Now you find for V1 and V2. So V1 equals 23 milliliters. And we're looking for V2, the volume of V2. So put the question mark right there. And all you got to do is just plug in the units into the equation. So you do 23 over 301 equals the question mark over 291. Right now you simple cross multiplying. Cross multiply. When you cross multiply 23 times 291, 6,000, 693. That equals 301. 301 V. Don't forget the units. Now you gotta get V by itself. By 301. By that. And your final answer is 22.23 for V2. Alright, you can stop it. Next law is Avogadro's law. And the equation for the Avogadro's law is V1 over N1 equals V2 over N2. And this, you know when to use this when you're looking at moles and ATM. So the example reads, a sample of nitrogen contains 1.5 ATM and a volume of 36.7 liters. The other sample has a volume of 16.5 liters. What is the number of the moles in sample 2? So first thing you want to do is write down your units. So V1 equals 36.7 and V2 equals 16.5. Bless me. Alright, so we know. So then we plug in the 1.5 because we know ATM is the unit for moles. And now all we gotta do is just plug it into the equation. So we do 36.7 over 1.5 equals 16.5. But we don't know N2, which is mole, the second unit for moles. So we put that question mark down. Now we gotta do now simple cross multiplying. Cross multiply these each other by, so I should do that. 1.5 times 16.5, 24 on one side equals, then we do 36, that equals 36.7, and because we don't know that yet, all we gotta do now is divide 36 by 24, 36.7. And when you divide those two, you get your final answer, which is 36.7, 6.7 into 6.7 ATM. Don't forget to put the units on there. 6. Alright, you can stop. The next one is ideal gas law, which is PV equals nRT. So the example problem reads, sample of hydrogen has a volume of 8.56 liters at a temperature of 0 degrees Celsius and a pressure of 1.5. What is the number of moles? So off the top, you know you're looking for moles because it just said that, and N is moles. Pressure is 1.5 ATM. I forgot to put the units. 1.5 ATM. Volume is 8.56. Then next, temperature. Temperature is 0 degrees Celsius, but we know that you have to put in Kelvin, which is this plus 273. So it would be 0 plus 273, which is 273. So, Kelvin. And R is never going to change. R is always going to be 0.08206. That's always going to be your R. And whatever ideal gas law problem you do, that's always going to be the R. So then you just plug everything in. You do 1.5 times 8.56 equals N times 0.08206 times 273. Alright, so we do the math for that. 1.5 times 8.56. 12 on one side. Then on the other side is 22.4 N. That's what you look for. And after that, you divide 22 to get N by itself. 22.4 to get N by itself. 22.4. Once you do that, 12.84 divided by 22.4. Final answer, N equals 0.57 moles. And that's it. Alright, so partial pressure. The law for partial pressure is Dalton's law, which the equation for that is P equals P1 plus P2 plus P3, so on and so forth. So the example problem reads, a mixture of oxygen, hydrogen, and nitrogen exert a total pressure of 288 kPa. If the partial pressure of oxygen and hydrogen are 112 kPa and 83 kPa, what would be the partial pressure exerted by nitrogen? So we know that we know that oxygen, hydrogen, and nitrogen all add up to 288. So basically what we do now, you would subtract 112 kPa by 83 kPa to find nitrogen. So we do 288 minus 112, 83, subtract, do the math for that. So nitrogen equals 93. 93 kPa. Don't forget your units.